Are animal models for neuropsychiatric disorders valid at the moment? Different neuropsychiatric disorders such as depression, bipolar, and autism are due to impairments in the nervous system. This year, 1 out of 4 people are affected by neuropsychiatric disorders. In addition, these disorders begin early in life. Despite the negative impact of these disorders, the knowledge about them remains scarce. For experiments, of course, humans are the best specimens. However, there are ethical and practical issues. Therefore, animal models such as flies, mice, and monkeys are required. Currently, many drug development studies quickly assume that behaviors observed in animal models are similar to humans' behaviors. However, upon looking deeper, scientists have raised many concerns regarding the validity because of 3 reasons: the subjective symptoms of these disorders, the subjective diagnostics test, and the early stage of genetics. The first reason is due to the subjective symptoms of these disorders. For example, in the case of depression, there are 9 symptoms and there can be a lot of combinations of symptoms. So which combination is to be used for animal models is not commonly agreed. The second difficulty lies in designing objective diagnostic tests for the experiment. Many symptoms are exclusive for humans, such as suicidal thoughts, and we cannot really affirm them in animal models yet. Also, animal models often do not capture the complexity of human symptoms. One popular test used to measure the level of stress in rodents is called forced swim test. While rodents are forced to swim in glass cylinders, scientists measure the time which rodents do not move. Typically, immobility representing stress of rodents is thought to be analogous to human stress. Antidepressants can reduce the stress level of rodents. However, a basic flaw here is that rodents are subjected to only short-term stress. For humans, depression is due to long-term stress caused by both genetic and environmental factors. The third obstacle is that while experiments depend on genetic information, our knowledge is limited. It is encouraging that animals have demonstrated certain changes which are similar in human diseases. For example, knocking mouse models made by inserting a mutation illustrate a number of brain degradations. However, the degradations are gentle and few neuron deaths are seen. This shows that the gene, while expressive in humans, is not very expressive in rodents. In addition, each genetic mutation contributes only a small percentage to the risk of having a condition. Likewise, though much effort has been spent on studying environmental factors, the low specificity of these factors hinders the progress to achieve valid animal models. Ultimately, the drugs experimented on animal models have not successfully cured humans, as during these drug trials, the underlying process is usually not investigated. Thus, these drugs, such as antidepressants, have many negative side effects. While animal models are mostly invalid at the moment due to poor clinical knowledge, subjective diagnostic tests, and unreliable biomarkers, they are by no means useless, as they are the best current alternatives to provide us initial results. To improve the validity of animal models, a suggestion is to wait for scientific advances in the field of genetics by studying more affected individuals. Furthermore, future knowledge in the field of neuroscience using fMRI and PET scans will also help us to build better animal models. Thank you very much for your attention.